on a coordinate graph. And what we're looking at today and what we looked at yesterday was finding midpoints, finding the lines of symmetry, the equations for the lines of symmetry, and then identifying the distance or the length of each side, and talking about what type of figure it is. Okay. Good morning. We're getting out our sheet of paper from yesterday, Luke. Okay, and Lene, we're getting out our figure from yesterday. We're looking down on that third quadrant figure. Okay, it's on there. Okay, so on this one, we are going to look for the lines of symmetry. We have already found some information about these. We did find yesterday that we got the midpoints. We did get those before the end of class yesterday. So now we're going to use those midpoints to find our lines of symmetry. Okay? Because if you look at our lines of symmetry here, down the middle, it goes through the midpoints of the two opposite sides. Okay, so we're going to use that to find the equation for the line of symmetry. We're also going to look at what type of lines these are and how we identify those from their equations. Okay, so those are the things we're kind of looking at. Okay, first, before we start that though, I want to ask, where do you see symmetry in the world? Do you see it anywhere?
Buildings.
Buildings, yes, some buildings have symmetry in them. We like to build with symmetry because that looks very nice. Okay, where else do you see symmetry?
Car windows.
Car windows. A car could have symmetry. Usually it's pretty much the same on both sides if you cut it down from front to back.
Yeah.
Okay. So what else has symmetry? Look across the table at somebody.
Faces sometimes.
Faces have pretty good symmetry.
Some people have unsymmetrical faces.
Well, I will agree that they might be slightly off. But for the most part, isn't your body symmetrical?
Yes.
We could go down the midline.
If you cut us in half,
Pardon?
My heart's on one side.
Well, okay, I'm going to say the
External.
outside, the external is pretty much symmetrical. You are correct. Inside, we are not symmetrical. Okay, but on the outside, we are pretty symmetrical. Okay, we have our two ears, we have our two eyes. We can go down the middle. The nose is pretty much the same on both sides. Yes.
What if you were like cut in half, and then like the one side of you was like flipped, but like still to where the wound was there, and like sewn together. So like your one leg was like up here, the other leg was like right here.
And your brain would not be connected to each other, so then you would not live.
Yeah, but that would be weird.
Okay, but there are people. So if you think of think about. Let's go back to realistic things. There's conjoined twins. Conjoined twins actually share one body in a lot of ways, depending on where they're connected, but their bodies are just opposites of each other. They share part of it, and then they go out somewhere, and you have they're symmetrical if you go right down the center of the two. That's why it's really hard to split conjoined twins, because they don't always have two hearts. Now, some that are just conjoined, like at the stomach or the belly button, and they go out from there, you have a lot better chance. Yes, their legs won't be, they'll have to do prosthetic legs and stuff like that, but that's a lot easier. And some are just met at the center, but they're symmetrical enough, but they have to have the two organs or it will not work for them to split them apart. Okay? It's a very dangerous surgery. Luke, did you have a question? You had your hand up. Okay.
Like conjoined twins, do they often like die at a young age?
Not often. I mean, often, yes. What is that word? Okay, I don't know. I do know conjoined twins have lived to be quite old together.
Cause that's just so like crazy. Like how
How does that work? I don't know because I've not been conjoined with somebody. But I do know the ones that have separate heads, they actually have different personalities.
Yeah.
But controlling, and I don't know how they decide who's controlling which arm or which leg if they're conjoined the rest of the way. That would be very interesting. But they have lived. Most of the ones that live are connected somewhere in the stomach area or in the down in the body somewhere, and then the legs may be separate, or they have different sets of hearts and stuff. The weird thing is their brains are usually separate, except for some are conjoined at the head. And then they may share some of the same brain.
That's crazy.
And that is crazy. Like I said, I have no idea how it works. I do know they can live to be quite old. Okay, I do know they have successfully separated conjoined twins before. Very risky, very risky surgery. Sometimes they've lost one and one made it. So it really depends on it. But yeah, conjoined twins are just kind of an anomaly that we don't really understand. And I don't think we can understand it unless we actually talk to somebody that is a conjoined twin, and we probably wouldn't understand it at that point either, just because we've never experienced it, so we can't really say, oh yeah, I understand that. No, I don't. So, okay, so other places of symmetry. Do we like symmetry? Do people usually like symmetry?
Yes.
Yeah, one
Yes.
things are often annoying.
Yeah, asymmetrical is not always what people go for. When we design buildings, we've kind of tried to do some symmetrical stuff. Maybe not everywhere, but in some parts of it, we like to do symmetry. When people do plantings, they like to try to get some symmetry to those plantings. And so they like to have symmetry. It's something in our minds that we are pleased to look at things that are symmetrical. Okay, yes.
Why does it say W for the top midpoint? Is that W?
Where's a W? This is midpoint.
No, up.
Negative, this
Right
one?
there, yeah.
Negative 13 and negative 6.
Oh, okay.
Okay. Oh, yeah, that's not a W. I see what you're thinking. Okay. Yeah. I know it's hard to read some of my writing on the board when I make it a little bit smaller. Okay. So let's go ahead now, and we are going to figure out the lines of symmetry that go through this rectangle. We have decided this is a rectangle. It has 2 lines of symmetry like all other rectangles. They have 2 lines of symmetry. And so we're looking for those lines as far as an algebraic equation. Okay? So what we want to get when you're doing lines of symmetries, what we want is y equals mx plus b, where m is the slope and b is the y-intercept. So we're looking for the description of our line where the slope is given and the y-intercept is given. This is something we did in algebra. Okay, so we're extending it now to be combined with our geometry because we're looking at lines of symmetry. Okay, so when we're looking at this, if we're looking at 2 points, how do we figure out what slope is? What is slope defined as? We talked about that yesterday. What was slope?
Change
Yes.
Y.
Rise over run is a good one. So slope equals rise over run. I heard somebody else say something. Was that you, Blake?
Y change over
Okay. The change in y? That's fine. I just have a change of x. Okay. So this one, we're going to look at this. We're looking at this line right here. Just looking at that line, just looking at it, is that line going to have a positive slope or a negative slope?
Positive.
Why?
Because it's going
Positive.
It's positive. Why?
It's going positive.
What is
Towards
it?
positive.
It's getting bigger.
It's going up, yes. It's going from left to right, so you have to really specify. From left to right, it's going up, okay? So we know the answer is gonna be positive. So we really don't need to worry about the positive, negative signs for our slope. We already know our slope is gonna be positive because it's going up. So what was my change here in my y's? I went from 7.5 to 11.5. How much did I change there? From 7.5, I changed 4, right? That was 4 points up. David, are we listening?
Yeah.
Are we writing down? We should be writing down this because I'm showing you how to do this problem. So everybody should be writing this down because we're going through how to do these problems. So when you get home and I have you an assignment like this, you know how to refer to it. That's why we take notes, okay? Okay, so our change in y went from 7.5 to 11.5. Our change in x went from 7.5 to 11.5. Still a change of 4. So my slope is 1 in this case because 4 divided by 4 is 1. It's positive. So I know what the slope is. So we've got one thing. We know what the slope is. We still don't know what b is. Okay, we know what m is, but we don't know what b is. Okay, so then what we do is we put the slope in our equation and we put one of the points in for the x and the y values. So now we have, now this is new, we have y equals 1m plus 1x plus b. We know an x and y that makes this true. We can take either of those points. Okay. So what we're going to do is we're going to say that y is -7, -7.5 equals 1x, which is -7.5 plus b. So all we did was we put a y in here and an x in here. We had the slope, we just figured that out, and this is our slope still. Okay, what we have left is just the b. Since we just have the b left, we can find what it equals. Okay, this was kind of interesting. It's -7.5 equals -7.5 plus a number. We're really going to add 7.5 over here, add 7.5 here. They both cancel, so that means b equals what? They both cancel. I have to have something on that other side. I have a b on one, that equals 0. Yes, because it's -7.5 plus 7.5. Here is where we absolutely have to write the 0 down. You can't just lose this side of your equation. Okay, so we absolutely have to write the 0 down. So now I know that the y-intercept equals 0. I know the slope equals 1. So I have my equation. The equation is now, overall, it's y equals 1x plus 0. Now, we could say that's just y equals x, right? Okay, that is the same as y equals x, because I don't need the 1 in front. It's an assumed one. I don't need to put the 0 on it, because plus 0 is just nothing. Okay, I'm not going to change it. So this is it in slope-intercept form, but this is a simpler form of writing it. Okay, so using that same process right now, I want you to find the slope and intercept, or the equation for that line. That's our other line. This is the line that goes through here. Question, is it going to be positive or negative slope?
Negative.
It's going to be negative. Okay, so find the slope of that equation.
1, 2, 3, 4. 1, 2, 3, 4. So change y. So that would be
I can
minus. That would be
Oh, there you go.
negative. But
Wait, what equation are we doing?
You're trying to find the equation now of this line, which goes through these 2 points. That's why I wrote these two up here, but I didn't put the negative on the 6.
Positive, not 7.
Okay, there we go. Gotta put that negative on the 6.
Would it be -7 over +7?
Yeah, we know the answer's gonna be negative, right? So all we have to do is say it's gonna be negative. Now find just the distance. So it'd be 7 over 7, yes, it would be negative 7 over 7.
So -1.
At your slope.
So just like go. So does it just go 1, -1?
It goes
Down.
down 1 and over 1, down
Okay.
1 and over 1.
So let's do
Now look for your
-6
intercept.
equals-
Why is B not equal 1?
Why does B not equal 1?
Yeah.
Because right here, this and this make 0 when I add them. So that makes 0.
Okay.
And we can't just drop it, we can't just say B equals, oh, I don't know, it's equal to 0.
What is -6 minus 13?
Okay, so
It'll be
how about
-8,
we're looking for the equation to find -6, -13, so
y
Negative 13.
equals -1
flip
x
those, -13, -6,
That's
you're at 20.
I mean, they're not that bad. Awesome.
So
Yes,
check this.
How is it?
No way.
Which part?
Is that intercept?
double check really fast.
No,
B?
it's like
Negative.
plus.
I just know so. And,
Okay, where you go slope, so y equals, there's the one edge,
Positive
right?
13, so we
Plus
add that.
Surplus.
Yeah, that's right.
And then you have to
Yep.
write down your equation.
Okay, so help each other if you need help.
Like, how many integers have you had to do?
Not quite.
You just have to find any.
So when we have a -1 times a -13. Positive, yes, positive 13 before we use the. We have to multiply the. Well, you could put either one in, you can know which one you wanna put in.
Plus, seven.
Okay, you can do X -13 over y -6.
So you just got that.
Hey, like,
Sorry.
And now you pick, now you see how you have to point -6 and -13? You plug it in, -6 equals.
So these are the change, but it's not negative, right? It's just a
no,
change.
so what I said is, what do we know about this slope, just looking at it? It is going to have a negative answer.
And you get 7 equals.
So then you just go the 8,
7 equals
8, which gives us. Okay.
What's B?
So our slope is -1. So,
Oh, it's the
No,
y
wait,
over
what?
x.
yeah,
Wait, let's see. So
What is B? No,
it
like,
doesn't matter,
in that
what you're
equation,
looking at is you're
what's
looking
the
at,
B reference?
okay, I know that is,
B is
and then
the
I
y
don't have to worry about the numbers. I
Oh,
really
is
just
that
have to
where
say, what is the
the
change
slope
between
crosses
these
the
2
y?
points?
Okay.
Oh, okay.
So it's negative 1 plus slope.
I don't know.
You want me to keep
So-
going?
so you.
Oh yeah, I want you to get the whole equation.
Yeah, it would be.
So you
-6
first,
plus
but you
13.
first have
Good
to
job.
multiply that,
Oh.
because it's.
So how do you find the
You
slope
have
first?
to let them distribute.
Okay, we know that
That's
it's
the
gonna
only
be
thing you did wrong.
negative, because see
Good
how
job.
it's going down,
I'm proud of you.
okay? So we look for how much did
13.
y change, or y change from 6 to 13, how much was that?
So
Seven.
-19.
How much did x change from 13 to 6? Just, again, not worrying about positive or negative, just the change. So it was 7, but we know the slope is gonna be negative, so we
So
take
you do
negative
this,
7
seven.
over 7.
You do -6
Okay,
minus
because
13
just
equals
looking at it, we
-7,
can see it's gonna be a negative
13
slope.
minus 6
Oh,
equals 7.
does
Okay.
it in the equation?
B 0?
Yeah.
Yeah.
Okay, okay.
Whoa.
Oh, now that makes sense. I
Or
understand.
wait, just positive, yeah. Wait, which one are we doing? It's
was-
negative, one, the first one.
Oh.
Thank you.
We can go to the gas station.
I'm mixed
after.
up now.
No, but-
I got it to
Please should not.
No, no, we're catching afterwards. and I'll get one.
Yeah, but not from my
Yeah, the
mom.
winter edition.
Let's see,
Yeah,
what,
yeah,
no,
I've
don't
never
do that
tasted
first,
kind of
multiply
artificial
first.
first. Like I've never tasted.
Order of operations, multiply first.
Craft mac and
Okay.
cheese.
I've never tasted that.
Okay, let me see
Is
what we
this-
have over here,
Craft
just a
mac
minute,
and
I'm gonna
cheese.
check this. Okay, so write the, oh, you did write the equation, okay?
I don't know.
We'll write the equation.
So you can prove that you
Miss
understand.
Miller, is
No,
B-
that doesn't prove that you understand, that proves that you can copy someone just writing the equation.
B equals
Facts,
zero.
but
No.
Don't copy, do it yourself.
Because on this one, you need to take an X or a Y put in here, which one are you gonna use?
Okay.
I did Y and X.
No, you have to do in this same point. So you would do X and Y
Oh,
from
I
this
see.
point. You can't use two different points to get it, you have to use one point.
Okay.
Okay, so that'll change that answer. Okay.
It doesn't matter which one you use.
Nope, doesn't matter which one you use. Either one works.
I
don't understand anything.
And it's Y.
Okay,
You
so looking at our picture,
Wait, is
From
it
those two
negative 15
points.
or normal 15?
is that slope
It's
negative or
negative
positive?
19.
Negative.
Okay, so it's negative.
So,
Now we don't need to worry about the
I think I put
negatives
in
and
the wrong
positives.
numbers.
What we just need
Oh,
to
right,
say
that
is
works.
if I went
So
from negative
you
6
can
up to
use either
13 or
one.
down to 13, doesn't matter, how many changes was that? What's the length between those?
7.
7, so that's on the bottom. Okay, cause that's your X. This is your Y, so how much did the Y's change? So we got -7/7, which is
Okay, yeah,
reduced
I
down
understand.
to
Yeah, that works.
-1.
I understand.
So once you have that, now we know Y equals -1x plus B. We're still looking for B.
Okay.
So now we're gonna put in an X and a Y. So one of the points, don't interchange, choose one point, so we're gonna choose this one. And we're gonna put that in, so
Okay.
-13 goes here, -6 goes here, and then solve for B.
Is this right?
No. Okay, so, you lost the number over here, you went to 0 here,
Oh.
right? So, let's look at this. What is this if I multiply?
-13.
Okay, so we really have -6. Get rid of that so you can see, equals -13 plus B.
Mm.
Except for our thing is -1.
I don't think so.
Our slope is -1, so this has to be -1.
Mm.
So it's really gonna be positive 13, because -1 times -13.
Oh, okay.
Now I'm gonna subtract this, cause I want B by itself. I don't wanna move the 6 over here, I want B by itself.
Oh, so you do that first then.
Yeah, yeah.
Yes. Fine.
Okay, so I think most people, a couple are still working on it, but this is what we get for it, is -1 minus 19. So y equals -1, because it has a slope of -1. Okay, so the slope is -1. Where it crosses the y, which kind of makes sense, look at your picture. Your picture is coming down there. -19 pretty much makes sense. Hey, David, see? So when we're looking at this, it says it crosses the y-axis. So if I continued my line down, it would cross at -19. And so look at your picture and make sure it makes sense. The y-intercept is where it crosses the y-axis. So the b equals -19 makes sense. Okay? Now, a question for you to think about. What do we know about this and this? Do we know anything about those two lines? Can you tell me anything geometrically about those two lines?
They're
Which two lines?
Perpendicular.
Yes,
yeah.
they are perpendicular. So the lines of symmetry in these are perpendicular. Okay, so let's just look. We know that this line then and this line are perpendicular. What do you notice about their slopes?
Are they the opposite of each other?
Yes, they're the opposite. If you look at the slope here, it's 1. If I look at the slope here, it's negative. So perpendicular lines, this is part of it. Perpendicular lines at least are opposites. Now I said at least, that means there is another thing that we're going to discover about it, okay? So those, at least, they are opposites. That's what we know, okay? So when you're looking on a graph, if you want to determine if two things are perpendicular to one another, the first step is look to see if they're opposites. If they're not opposites, you know they are not perpendicular right from there. Now there is one more condition that we have to add to that. I'm going to write plus one more condition. We're going to figure that out as we do some other ones. Okay. So there we go on that one. Okay. So now, what I want you to do for your homework, and I'll put this online, is you have 2 more figures. Okay? You have 2 more figures that are on your sheet. They are in quadrant 1 and quadrant 4. We have not done the lines of symmetry on those. So what you're going to do for each of those is this. So first, we've already identified what they are. I think we found the links in the triangle. Is that correct, or did we find all the links? Anyway, I'll just put find the links of all sides in the figure. Okay, so you're going to work on just the triangle first. Give me the links of all the sides and show some work how you got it. Some of them are going to be easy. So if it's like this and this, these are going to be very easy. I think we might have identified those already. Okay, so but the other ones you have to use the Pythagorean theorem or the distance formula. Okay, so find all the links in the figure. You're going to do it for the triangle, and then you're going to do it for down here. And so you need to look at those links. Second, you're going to draw a dotted line for all symmetry lines. Okay, so draw the dotted line to represent the symmetry lines. Does that make sense? Just kind of like we drew it here. Okay, so draw those lines. If you have 2 points already marked, so find the equation that goes, the equation for the symmetry line. Line that goes through two vertices of the figure. Okay, so this is if possible. So this one didn't go through the vertices of the figure. Okay, so make sure you guys understand what I'm telling you here. So in step 3, if it goes through the vertices of the figure, go ahead and find the equation for the symmetry lines. Line or lines, okay? So it could be more. But this is only if you have it going through the vertex of the figure, okay? Then step 4 is going to be find the midpoints of the line or of the side if the symmetry line of the sides, if the symmetry line does not go through a vertex, write this down please, and 5, find the lines of symmetry for the line for the points not on the vertex. Okay, so I'm going to give you a hint. In quadrant 2, yesterday we did a kite. Okay, so in quadrant 2 yesterday, we did a kite. It went through the vertices of the figure. The line of symmetry went through those vertices. So we only had to do 1, 2, and 3 because we didn't have a line that went through the midpoints. Because it only went through the vertices. Here, for this one, it didn't go through any of the vertices, so we're going to skip number 3. So you skip number 3 if they don't go through the vertices. It only went through the midpoints of these opposite sides. And so then you go up to 4 and 5. So you're either going to do, and you may have lines that are both through the line of symmetry, that is through the points in the vertice, and you may have a line of symmetry that goes through midpoints. So you have to look at that very closely to see what you have. Okay, so you're going to do that for the triangle and the octagon that we had yesterday. Okay, the triangle and the octagon. I'll let you ask him for the points for those, or for the drawing. See how he has them there. You can get them from him. Okay. Questions on this? Please either take a picture of this or write it all down. If you want to take a picture, that might be easier. But you're welcome to do either one. That way you have that information.
Is this for problems for this week?
This is one of the sets of problems for this week. Yes. See, I'm going to actually take a picture too so I can upload it and give it to you guys. Oh, but I have to know how to figure it out.
It'd probably be better if you did it right there, so it's a
That's
straight
probably true. Thank you.
so there's no glare.
Well, I don't guarantee there's no glare.
You guys will be okay.
Okay. Okay. So that was basically from yesterday. That's the continuation of finding lines of symmetry on the coordinate graph. So we're doing geometry because we're identifying lines of symmetry. We are identifying the types of figures that they are. So that's part of geometry. But we're adding in the algebra part when we find midpoints, lines, links of sides. We're adding in those kind of things that are really considered algebra. Because remember, this is a joint thing. It's geometry and algebra together. So we're going to figure out things about geometry, put them on the coordinate graph, and then learn how do we do that in algebra. Okay, I'm going to go ahead and erase this. And I'm going to actually turn this off for a minute.